Good morning. Right. My name is Arun Gupta, and today we'll talk about how to deploy your microservice architecture using AWS Stack primarily, and then one of the components that I'll be using over there is Couchbase. So my goal is to kind of give introduction to each part of the stack, like what is serverless architecture, what does Lambda look like, what is the role of S3 in this component, what is API Gateway role, what role is being played by API Gateway, and finally, what is Couchbase. And essentially put those all together to build a very simple microservice. I won't go into the details of what microservice architecture is, what are the key components of microservice architecture. So we'll straight away jump on, actually building an application and showing you what it needs to be done. About myself, I'm a Docker captain. Been talking about Docker for a long time. I'm a Java champion as well. I've been talking about Java for many, many, many years. Bunch of other things. I like to run. I'm an author of several books for O'Reilly, and I'm a lifelong learner. I'm always ready to learn. Whenever I give these talks, I always end up learning more from the attendees, and I try to teach a few things as well. And something that I personally believe in is DevOps for kids. As you guys saw in the opening keynote this morning, DevOps for Kids is an initiative to teach kids and get them excited about technology at an early age. So I run the organization in US, and we have several chapters across US, which I am happy to coordinate. Now, in terms of microservice, this is sort of the definition, the Uber definition that is being used and was given by Martin Fowler, essentially. The key components of this microservice architecture are really highlighted in the red part of it. I want to talk about them for a few seconds now, and then I'll talk about it again at the end of the section, at the session rather, so that we have a better understanding of it. But the key parts, as we see here, is these are suite of small services which are fairly independent, running in its own process. Each unit is independently deployable. So now in case you need to upgrade a unit, you should be able to upgrade it independent of others. There are lots of mechanisms that goes as part of that. CI/CD, service discovery, scaling, all of that becomes part of that process. Minimum amount of centralized management. There is no central management plane, but you still have monitoring, which is quite central. So these two are different aspects of it. It's certainly using different programming languages and different data store technologies. It's not tied to a stack that you must use Java EE or Spring or Node or something like that. End of the day, you are really communicating using lightweight REST API. And then in terms of the data store technologies, you are looking for a solution which solves a problem. You're not saying, hey, here is my solution, what is your problem? So if you want to use NoSQL, sure, use that. If you want to use relational, sure, use that. Or if you want to use a caching that solves your purpose, that's fine too. So at a very high level, if I were to look at how my microservice architecture is going to look like, essentially it's a bunch of web pages, some JavaScript in there, which I'll throw it together. They are invoking a bunch of REST APIs. Those REST APIs need to be, authenticated, authorized, and they eventually invoke some code at the back end. And that code eventually performs a business logic, and that business logic stores, reads, updates, deletes data from a database. Independent of how my service discovery is done, how these services scale up and down, what happens behind the scene at a very, very hypothetical way. This is sort of how my typical any application would look like. How they are packaged, of course, defines what a microservice would look like. If I were to further up-level myself, this is sort of my typical MVC architecture as well, where the REST endpoint is my controller, which is really guiding where the application should be directed to. My model is really sitting back in my code and my database, depending upon how you define it, and view is, of course, all done using web pages. Just simple HTML, JavaScript, essentially. How do I implement that using the stack that I just talked about? Well, think of this. My web pages are essentially a bunch of HTML and JavaScript, as I said earlier. My REST APIs are essentially get, put, post, delete. That's essentially what I am communicating using. My code, all of that code could live as a serverless application, and my data could be sitting into any data state technology which in my case would be Couchbase, for example. I'm using Couchbase because I work for Couchbase, but by any means, you could use any data store technology, which is sitting anywhere where you like it to be, okay? So this is sort of the stack that I'm gonna walk you through and help you understand on how do you build a simple microservice using this sort of the stack. And all along the process, I will keep sharing what each of the component does and how we implement that. All right, let's take a look at serverless computing. But before we get in there, what are some of the challenges that we faced with a server-based computing? Server-based computing is you spin up a bunch of VMs and then you need to analyze, okay, what size server will fit my budget/performance? Should I use a T3? Should I use a M3 medium? How many of those should I spin up? Does it meet my budget requirements? How do I scale them up? How do I scale them down? Yes, you can set up metrics-based performance as well, but that's a bit of a work that you need to do yourself. What operating system should I use? Should I be using Ubuntu, CentOS? Those kind of decisions kind of come into play. So there is a bit of a work involved if you go with a server-based computing. What should my operating system settings look like? Are they optimized for performance? Do they have the right patches? What if a new patch is available? I need to upgrade my operating system. Who's gonna update that operating system? How do I control access to servers? I need to set up authentication, authorization. And then last but not the least, I need to now deploy new code to the server. So these are some of the typical challenges when you're doing a server-based computing. Now, there are known solutions to this, but this is sort of a known devil that we have to deal with. And that's where sort of, your serverless computing kind of comes in. If you look at the past 20, 30 years, essentially, look at the way industry has evolved, virtual machines and then recently containers, and then going forward, what we're looking at is containers. So let's sort of compare and contrast on how these three different programming realms, so to say, compare. In terms of these three different programming methodologies, the unit of scale for VMs is essentially a virtual machine. In terms of container, it's an application because you package your application as a container. Docker container, you have different orchestration frameworks which allow you to scale each Docker container independently. And in terms of a server, essentially your application consists of multiple functions. You break down your application into multiple functions, and then your unit of scale itself becomes function. In terms of abstraction, for a VM, your abstraction is really hardware. You don't care about what hardware is being used underlying. In terms of containers, you are running a Docker container. Whether it's running on a Windows or a Mac or a Linux, it doesn't care. You don't care about it. And similarly, in terms of serverless, you're saying, hey, here is my function written in Java or in Node or in Python. Just go run it. I don't care where it's hosted, what hardware, or what operating system. You just go run it. In terms of packaging, for virtual machine, you're really looking at AMI. That's sort of the standard terminology that people use from AWS LAN. In terms of containers, you're really looking at your container file, which is essentially a Docker file. And in terms of serverless, all you care about is my code. Hey, here is my business logic. Just go run it somewhere and scale it. In terms of configuration, if you're using a virtual machine, then you need to configure your machine, storage, networking, operating system, all of that needs to be configured. In terms of containers, you need to run server. You need to still run those containers in a virtual machine. So the configuration of the application, scaling, all that needs to work out. In terms of serverless, you store the code somewhere and you run when it's needed. In terms of execution model, of course, VMs are multi-threaded, multitask, and multi-threaded applications are always typically a lot challenging to handle. In terms of containers, again, multi-threaded, containers do one thing and one thing really well. So it's multi-threaded, single task. And in terms of serverless, is single-threaded, single task, highly scalable. Runtime, containers are a huge improvement over virtual machines as opposed to hours to months. By provisioning a traditional hardware, you're actually saying hours, a few minutes for virtual machines. For containers, you're really bringing it down from minutes and days to like a few seconds. And in serverless, you're really talking about microseconds to seconds, on how quick it is to provision code. Last but not the least, in terms of unit cost, we're really looking at per virtual machine per hour. That's the unit of cost for VMs. And then in terms of containers is still you're running on a VM somewhere in the cloud, so it's still per VM per hour. But in terms of serverless, what you're looking for is per memory per second per request. And we'll talk a little bit more about the serverless model so that you get a better understanding of this. And this is the last part of it, basically. If you look at AWS, essentially, you're really looking at EC2, which is sort of the standard way of provisioning your VMs. And in terms of containers, you're not only looking at Docker, but other orchestration frameworks like Kubernetes, ECS, DCOS, on how these containers need to be scheduled. And then serverless kind of gives you AWS Lambda. Okay, that's where you provision your serverless functions. Another look at the abstraction from serverless perspective. If you look at in terms of comparing with IaaS, container as a service, platform as a service, and function as a service. This kind of slide gives you a quick overview of what sort of the abstraction done by the vendor and done by the user. Now the IaaS, CaaS, and PaaS are sort of well understood, but if we really look at the FaaS part of it, is you can see most of it is actually managed by the vendor. From your perspective, all you really care about is function. That's my code, that's my logic. I'm going to put the logic in there and let the vendor take care of running it wherever it needs to be run, fully optimized. Okay. Adrian Cockcroft works for AWS now, and he says, people typically confuse between PaaS and FaaS. Even though we call it a serverless, so that's a misnomer by itself, first of all, because it's not really serverless, because there are servers behind the scene that are still running that function. So I would rather call this as FaaS, or function as a service, essentially. But the point being, if you are confused between PaaS and FaaS, how they differ, this is sort of a very good tweet that summarizes it, because functions essentially run for a few seconds and then they disappear. And then they run for a few seconds and then disappear. If your PaaS can do that, then you can compare and contrast the two. So what is AWS Lambda? AWS Lambda is an implementation for FaaS, or serverless computing. It's fully managed. There is no provisioning that needs to be done. Essentially, you create a function, which is your business logic. You upload it to AWS Lambda, and AWS Lambda takes care of running it. Today, you can build your function in Node, Python, Java, and C#. Those 4 languages are supported. You say, here is my function written in this language, and they support those runtimes. Zero administration required, because it's run all as a managed service, and it's highly available. You can set up in different regions, zones, the way you care about it. Sub-second metering, which is sort of the most awesome part of it. As opposed to saying per VM per hour, you are really charged by 100 milliseconds of execute time. There is no cost for storing the function in the cloud. You write a function, you upload the function in the cloud, it's sitting out there, but the only cost is for the execution of the function, which is sort of the cool part of it. And last but not the least is, because it's zero administration, you say, okay, now go run it. If you're receiving thousands of concurrent requests, AWS Lambda, looking at the AWS infrastructure, automatically scale it up and down. If you're receiving 100 requests, it's going to run 100 concurrent requests of your serverless function or a function. If you're receiving thousands of requests, it'll automatically scale up and down. You don't really need to do anything about it. So how does it work? Well, you write your business logic, and I'll show you a sample of that. You write your business logic, you upload it to AWS Lambda. You can upload it using AWS console. You have Maven plugins, all sorts of stuff is there. Once you upload your code in AWS Lambda, the code could be triggered by different events. The event could be a simple API. The event could be an IoT device. The event could be from a web application where you say, go ahead, trigger this function. So event could be image upload in S3 bucket. Image could be a table update in DynamoDB. Lots of different events. So that's sort of how the functions are triggered, essentially. And once the function triggers, the function is run into the runtime in AWS, fully managed for you. Now, behind the scenes, Lambda also runs containers, but it uses LXC containers to execute those functions. And last but not the least, from your perspective, you only pay for the compute time that you use for the function. So sort of a simple flow that is you need to understand if you're getting started with AWS Lambda functions. AWS Lambda pricing, very cool actually. There's a free tier. Now, typically during your development phase, you would generally not exceed 1 million requests. Any free tier, whether existing customer or a new customer, you get a free 1 million requests of your function execution. And the way compute time is executed is 400,000 GB seconds of compute time. because essentially when you create your function, when you upload a function, you say, oh, it's going to require 128 kilobytes of memory, or 256, 128 megabytes of memory, or half a gig of memory. And then accordingly, your GB compute time is calculated. And then that's based upon that, they say, okay, how many free requests are available to you? Now remember, here you only give the compute time. The CPU and the network are not controllable, and they're allocated appropriately for you. So you only worry about the compute time, essentially. And even after that, it's charged like 20 cents per million requests thereafter. So the pricing is very, very down to the ground, depending upon, very granular in that sense. And here you get a view of what the pricing looks like. As you can see in the left column, this is the memory. It talks about the free tier, seconds per month. If you're really using 128 megabyte function, then you really have 3.2 million calls that are available to you. So depending upon the runtime, you can easily tune that and play around with those numbers. So what are some of the use cases for AWS Lambda? You may think, if it needs to be triggered, can it be used for a certain kind of application? But these are some of the use cases for AWS Lambda. Well, think about a photograph being taken. The photograph is uploaded to S3 bucket. As soon as it is bucket, because Lambda can be triggered by an event, you can say, as soon as an image is loaded in this bucket, trigger this function. That serverless function can automatically generate your thumbnail images and store it into the S3 bucket. So a bucket, an image getting uploaded, and automatically your thumbnail images are generated by the serverless function. Another example, very classical ETL example here. An online order is placed here. An online order is placed. The data is stored in DynamoDB. Any row getting updated in DynamoDB can then trigger a Lambda function, and then the Lambda function can talk to Redshift, run a full transformation code over there, and generates the analytics data from that DynamoDB row, essentially. So that's, again, a very classical enterprise use case here. Another example here is, you have a front-end code and a sort of a weather application running in S3. As soon as you click on a link in your weather application, that talks to the API Gateway. API Gateway is basically where your REST APIs are provisioned. And as soon as you click on the API Gateway, a REST API is not click, but your REST API is invoked. That REST API then passes the information to the Lambda function, which then executes and stores data into DynamoDB and basically queries the data from DynamoDB. And that's sort of similar to the use case that we'll be talking about today as well. So what are my key components of my Lambda function here? Now, this is a very, very simple Lambda function that I'm explaining here. It's just a simple hello world class. It implements request handler interface, takes a request and a response, which are simple POJOs, essentially in my case. The handle request method is the key part here, which comes from the request handler interface, which I need to implement. In that, there are two parameters. The first one kind of gives me what the request looks like, which is sort of my payload of the message coming in. And the context is what gives me the runtime of the Lambda, where I have more detail about the Lambda runtime itself. So if I look at it, here it defines, I'm using Java as the language runtime here. Then I got the data passed to the function itself. And I typically pass JSON data. And then in the body of the function, I can say request.firstname, request.lastname is how I'm getting that data. And then I can return a new response, which is basically my POJO being populated with the response, and I return it back. And context is what gives me the Lambda runtime. So these are sort of my key components of AWS Lambda. Now, if I were to build a simple function like a AWS Java plus Lambda function, how would it look like? Let's take a look. By the way, all the code that is here is available on my GitHub repo. So this is Arun-Gupta/serverless. That's sort of my GitHub repo where all the code is available. You're welcome. You click on the AWS link here, and all the code that I'm showing you over here is definitely available there. Now, here is my hello world here. This is the same code that I showed you, essentially request handler. And if you look at this, this is really coming from Amazon AWS libraries here. So nothing fancy. If you look at request, it's just a POJO making sure that my JSON inbound request is mapped to this request automatically. And then this is a response, again, a simple POJO. If I look at my project files here, this is a POM XML, and it's a very standard POM XML. All I got is a AWS Lambda Java core. Those are my AWS APIs that I'm importing here. And then all I'm doing is I'm just saying a Maven shade plugin, because that plugin essentially allows me to generate an Uber jar. When I have to upload my code to Lambda, then I need to create a Uber jar, bundling all the dependencies, package all the dependencies, one single jar that can be run by itself. And that's what this Maven shade plugin gives me. And once I create this, then I just upload it to AWS. Let's take a look at that. So how do I deploy my first Java Lambda function essentially? We talked about the Maven dependency that is needed in my POM XML. Now I am using AWS CLI essentially here to upload my function. And let's look at this particular method here. So if you look at this is AWS Lambda create function. I'm saying the function name is hello world. I need to create a role, because if you are creating a Lambda function, you need to be in a certain AWS role, and the requirements of that are clearly listed. I'm saying the handler, which is basically the main handler in my Java class, which is going to be invoked, which is sort of the entry point to my Lambda function. Then I'm saying the zip file. Essentially, this is the jar file. This is a jar file that was created by Maven package, and by using the shade plugin. Then I give a description. Then I give the runtime here that I'm using Java 8 as a runtime. Then I'm specifying the region, the timeout, the memory size, and then I'm saying just publish. Because by default, it uploads the function, but it doesn't publish it. But I'm saying, in this case, just publish the function as well, so that it can ready to be invoked, okay? So now what I can do is, I can literally copy this code here. And if I go to hello world, I can give this target here, or give this command here. Now this is gonna upload the function to AWS console. And if I go here, I go to console. Now remember, this was US West 1 region. So if I log in here and I say, show me Lambda, I got a bunch of functions here, but this is the one that we just created about 19 seconds ago. And I can get more details about the function right here itself. If I want, I can test it here, but now what we're going to do is, I'm going to copy this command here, and I'm going to remove the hello world.out file, which was already existing from a prior run. But if I look at it, there is nothing else in here, and I can just simply invoke it. And here is my payload. This is a JSON payload that I'm passing on. And remember, this first name and last name were my field names in the request POJO. And I'm saying dump the output into hello world.out, and that's it. It says status code 200. That means the result is successful. But then we can look at hello world.out, whatever greetings that we were returning from the Lambda function, that comes back to us, and dump the output over here. Okay, so that's sort of a very simple Java plus Lambda function that we ran out of the box, and showed you here. All right, let's take a look at Couchbase. So we got a simple Java Lambda function. If you think about this, that's my very tiny microservice. It's got no state. It's got nothing in there. Every time I run this, my Lambda function is invoked. It executes it, and the environment is discarded. If I want to upgrade it, I just upload a new jar file, and that's it. That new function gets executed accordingly. If I wanna run multiple concurrent execution of this, I say, I can run it accordingly, and the Lambda function will scale behind the scenes automatically for me. So in that sense, it meets those requirements for my microservice here. So what is Couchbase? Couchbase is an open source NoSQL document database. Some of the functionalities that it has is, of course, it can store your JSON data natively, as is because it's a NoSQL document database. You can run full queries on it. We have this language called as Nickel, which is SQL-like syntax. I would encourage go talk to the people at Couchbase booth, to learn more about Nickel query syntax. But essentially, you can write your SQL queries to query the JSON data. Then of course we can create all sorts of different indexes. As a matter of fact, in Couchbase, you can create 9 different types of indexes: global secondary index, primary index, secondary index, all different kind of indexes. We also have replication capabilities where there is one primary object and then there are a bunch of secondary objects as well. We also have the ability to do cross data center replication across different geographies. That's a possibility. One of the things about Couchbase that people typically love is Couchbase Mobile, where you can have a database sitting in your mobile device and be automatically synchronized with the backend server. So you can have multiple mobile devices, and instead of using SQLite, you can use Couchbase Mobile sitting in your mobile device and then be able to communicate with the Couchbase backend with offline capabilities. Search and analytics are some of the new functionalities that are getting introduced in the newer releases as well. So my next Lambda function essentially is, I wanted to say, okay, you know what? I built my Java plus Lambda function. Now, how do I communicate with a simple Couchbase database now? So let's take a look. Again, it's very simple. Well, essentially what I did is in this case is, instead of invoking it directly, I used, I think I should have a slide on that. Yeah, I think let me talk a little bit more, then I'll explain. So essentially what I did here is, it's the same dependency which is shown in number 1. The process of creating a Lambda function is pretty similar. When we're saying AWS Lambda create function, region, zip file, all of that. Invocation is very similar as well. The key difference is when I'm creating the Lambda function, in this case, I'm just passing an environment variable. This is a new functionality introduced, I think, October or November of last year. But essentially what I'm saying is Couchbase host this is where my EC2 it's my basically EC2 instance where Couchbase is running. Using Couchbase, but you can use any database essentially. Okay. So the sample that I built is, I got a simple AWS IoT button. With the IoT button, every time I click on the IoT button, instead of me manually invoking and triggering the function, I'm going to say the trigger is going to be from the IoT button. Every time I click on the IoT button, that'll go trigger the Lambda function. The Lambda function is then using the Couchbase Java SDK to store data into Couchbase. And the fun example of this was where we were ready to install 2 IoT buttons in our cafeteria. Now, on every Thursday, we get free food at work. So we said, okay, we'll install a red button and a green button. Now, if you like the quality of food, you press the green button. If you don't like it, you press the red button. And all of that data automatically goes and sits into the Couchbase instance. There's just a geeky way of giving feedback about the food, but it kind of shows you on how geeky you can get with serverless. So let's take a look at this here. Now this is my hello Couchbase Lambda here. It implements the same request handler interface. In this case, I'm still using a request bean, but I'm returning the response as a string. Every time I'm getting a request, I'm just saying, okay, here is my simple date time format. I'm getting more information, meta information, because I know the request that is coming to me is in the button format. So I'm creating a button document because that's essentially what I want to store into the database. From the, if you look here, this is my context. From the context is where I'm getting the request ID, because every time essentially when you click on the button, that request ID is passed over to you. So you're trying to get some unique information over there. And then you're setting the timestamp. And then from the Couchbase itself, you're getting a bucket here. So I'm saying, okay, connect to the bucket, get me the bucket instance. And in the bucket, which is sort of a table in a Couchbase language, and you store that JSON document into the Couchbase instance itself. So it's very simple, similar logic, but this time we are actually storing data into the Couchbase itself. And if I go back to my POM file here, there is no difference in the POM file. The big difference, well, the big change really being, I'm just including the Java client as well. And as we talked about is when we're building a Lambda function, we want to integrate our libraries as part of it itself. And the Maven Shade plugin pretty much stays as is. All right. Now that's sort of the Lambda part of it, but there are other key parts of the application as well. So AWS API Gateway. Well, what is AWS API Gateway? It allows you to create, publish, maintain, monitor, and secure your RESTful APIs. So with Lambda, but typically if you're building a Java EE or a Spring application, then those platforms themselves have ways to publish REST API, but you got to live in their way. But in terms of serverless computing, because you are publishing a Java function, there is no way to expose a REST API by itself. So you'll have a serverless function, which is where the business logic is, but you want to delegate the REST API to an API gateway. And some of the advantages of that are because the API gateway can then manage your multiple versions of the API. You can even manage different stages of the API, that this is a dev stage, this is a production stage, this is a testing stage. So you can have different stages of the API, which gives you the ability to iterate, test, and release new versions, or even fall back to a previous version of the API if needs to be. You also have a visual dashboard, which allows you to monitor your API usage. And it is also very well integrated with the AWS CloudWatch, where you can see all the monitoring logs. You can configure any amount of APIs, and just like serverless, you only pay for the APIs that are being invoked and the data that is transferred out of those APIs. So configuration of the API itself does not cost you anything at all here. A little bit more details. It also helps you with denial of service attack. For example, you can start setting up throttling rules that, if I'm getting more than 1,000 requests, then throttle the server. Just don't allow more than 1,000 requests per second or per concurrent users to this particular serverless function. And you can start setting up those rules. It is very well integrated with, again, complete AWS infrastructure for authentication, authorization of your APIs. And one of the cool things about AWS API Gateway is itself that once you have configured the API, it will generate your client SDKs, so to say, for JavaScript, iOS, and Android rather. And then you can start invoking those APIs directly from those SDKs. So what would my typical API call flow look like? You have either a mobile app or a desktop app or a web service sitting on the front end, and those are coming over internet. Then those really go to the Amazon API Gateway, because end of the day, any of those applications are trying to invoke a REST API. The REST API, it can integrate with the API Gateway cache, so that in case you want to return a response, hey, the request just came like 2 seconds ago, I'm going to return a response right away. So you can do that. Or it can just dispatch to the actual function where you say anytime this API is invoked, invoke this serverless function, or invoke this particular business logic which is sitting in EC2, or another third-party publicly accessible endpoint. API Gateway, the beauty of this is completely independent of what's in the backend, whether it's AWS sitting on AWS infrastructure or sitting somewhere else. So in that sense, AWS API Gateway is a fully independent functional product by itself. And last but not the least, it is very well integrated with Amazon CloudWatch monitoring. So you can start looking at the stuff that's happening at the API level itself. So what I did is I built a simple microservice essentially, and this microservice, is the goal of this microservice is essentially to CRUD some book data into a Couchbase instance. And in this case, essentially what I'm doing is I have an API gateway sitting. Well, let's take a look at this. So here what I'm showing you is a console, AWS console. It shows my APIs the way they're configured. It shows my /books URI. It has get and post two methods. It gives you that those get and post methods are then in turn invoking the Lambda functions for me. So how does my architecture look like in this case? Well, I have a client. The client could be a curl client because essentially it's a REST API. So I could have a curl client, a browser client, a mobile client. I don't care because end of the day it's a REST endpoint for me. The REST endpoint is hosted by the API gateway. The API gateway, the APIs particularly in that gateway are configured to go and talk to the Lambda functions. So I have a book list and a book create, two separate Lambda functions sitting up there. And then they both talk to the Couchbase cluster that could be running in the backend in EC2 for you, for example. Complete details about how to get this up and running are explained in the blog that are over here. And as I said, the slides also are available in my serverless GitHub repo. So let's take a look at this actually. Go back here for a second. So here is the diagram that we talked about essentially. Now we do need the IAM roles. So we need the identity and access manager roles. So we create those access manager roles. We give it certain trust responsibilities. Once those roles are created, these are my trust policies. I'm going to create my Lambda functions. If I go back to NetBeans here is my microservice HTTP endpoint. If I look at the source code here, I'm going to talk about this gateway package in a bit. But if you look at this here is my bucket get all function. It implements a request handler, takes book as the input and string as the output. And all I'm saying is, okay, you want to give me the list of all the books. And this is, again, I'm using Amazon APIs and I'm using Couchbase APIs here to do the selection. So you can see how the code is being matched very appropriately. And then here I'm generating a result while generating a response, and then I'm returning the result here. Okay, all the methods pretty much perform like this. So if I pick bucket get one here, I'm just getting a book here. I'm getting the book ID, and then based upon that, I make a query to the database and I return the result. So you can see how when we talk about microservices, typically we are talking about addressing a single business concern. So depending upon how extensive, how deep, and how wide you want your microservice to be, you can start addressing those concerns based upon how your functions are designed, essentially. And in this case, all I'm saying is, hey, just return me the list of the books. So that is typically my microservice here. So what is my typical development workflow essentially? Well, what I would do is I would typically write or update a simple Lambda function, whatever that Lambda function needs to do. So I'm going to test that Lambda function that, okay, this Lambda function works by itself. So that's golden. Once that works, then my second step really is I'm going to create a REST API for that. That REST API is created using the REST API, AWS API Gateway. And as I showed you a snapshot of the console, it can be very easily created, but there are easier ways to do that as well. Then once the API is created, then I'm going to say, oh, by the way, this Lambda function is going to be triggered by this API. So every time this API is called, go trigger this Lambda function. So then once those two are connected, then every time I invoke the REST API is going to trigger the Lambda function, which in turn might be storing data into a Couchbase instance. I test, debug, and then rinse and repeat. So I just keep doing that cycle again and again. So that's sort of my typical development workflow. Now, that's too much work for me. Do I focus on serverless? Do I focus on API gateway? How do I link the two? That's too much stuff for me to understand. So AWS introduced something called as a serverless application model, which simplifies all of that integration for you, where it does allow you to integrate all of those into a single document. Now, AWS has this CloudFormation templates, which simplifies, deploying different artifacts, different components of AWS infrastructure very easily using a single CloudFormation template. So for example, let's say you want to create a Couchbase cluster. If you want to create a Couchbase cluster, then you want to spin up four EC2 instances. On each of those instances, you need to configure Couchbase. Then you create a cluster, then you create the authentication user, all that. Now you can write a script, or you can do it a CloudFormation way, where you can automate all of that. And then you say, okay, go spin up the CloudFormation template, and it'll do all the good things for you. So essentially, serverless application model extends that CloudFormation template, and it adds new types. One is for the function, of course. One is for the API, and it allows them to connect with each other. And then it adds a simple table API, simple table resource as well, which allows you to connect with DynamoDB as well. And then it has some new event sources and property types. So let's take a look at it. How can we leverage this serverless application model for deploying our microservice? So here is my simple microservice, essentially defined using serverless application model. So if I look at it on line 1, essentially what I'm saying is this is my template version. This is the CloudFormation template version. Then I'm saying, okay, this is my serverless application model. This was introduced on October 31st. So that's sort of the namespace that I'm using for the transform. Description is my own. And in this case, I'm defining my different resources. What are my resources that's going to be used as part of this serverless application model? I'm saying line number 5 says this is my resource name. And I'm saying this is a simple serverless function, which is line 6. Then basically from line 7 all the way through 16 is where I'm giving all the different properties. Remember we were saying AWS create Lambda function. Instead of doing that CLI, I'm putting all of that information into this simple YAML file. The main difference here is instead of uploading the code from my local drive, I have to upload the code to a S3 bucket, and then it'll automatically fetch the code from the S3 bucket and deploy your Lambda function here. Okay, and then line 14 and 15 shows essentially, hey, by the way, my Couchbase is running on this EC2 instance. So this one YAML file, you can just say, okay, take this YAML file and generate this serverless application model for me. We'll do everything for you. Step 2. So that is just doing the serverless function essentially. How do I connect it with an API gateway? Well, that's where your line 40 to 46, or rather 41 to 46 comes in handy. This was added recently. So you can see I'm saying that, okay, microservice get all gateway is sort of my resource. And this resource is a serverless function. And then line 41 to 46 says, what are the events that are going to trigger this function essentially? And in this case, I'm saying, oh, by the way, this is an API. Line 43 says that. And then I'm saying, okay, the properties are /books and the method is get. So I don't need to mess around with the AWS console in any sense this way. All I'm saying is, hey, by the way, take the serverless application model, go ahead, create my resources because it's automatically extending AWS CloudFormation templates. So it will generate the resources for me, make sure my function is created, make sure the API gateway is connected with the function, and all of that is golden for me. So this essentially will generate my resource and my microservice as well. Now, what role does S3 plays in there? Well, we know all the goodness about S3 and not so good things about S3 when it fails. Well, it's simple, durable, scalable, all those, I'm not going to quote those numbers. It has all sorts of access types, authentication. It's very well integrated. The cool part is durable in the sense it talks about 11 nines of durability once it's stored over there. Some of the S3 concepts that you want to understand, S3 has buckets, and then in each bucket you store an object. The object itself has metadata and data. Data is sort of completely opaque to S3. S3 doesn't have any information about the data, but metadata is what is interesting. It has got a key and it's got a version. And what uniquely identifies an object is a bucket, a key, and a version. That's sort of what it identifies. So you could upload a new object with a new, with the same key, but it will be given a different version. So you can have different versions stored in there. Okay. How is this relevant? Well, I can upload. One of the things that S3 can be used, which I didn't know until recently, was how you can host a static website on S3 very easily as well. By static website, if you recall what we said earlier, by static website I mean is simple HTML and JavaScript files can be uploaded over there. And because S3 offers all the capabilities of cross-region, cross-AZ availability, it can be integrated with with your CloudFront for your CDN. It can be integrated with Route 53 for your DNS mapping, all of that. So by hosting your static website on S3, essentially HTML and JavaScript dumping it over there, you don't need to think about where should my server should sit like. Okay. So I can configure a bucket to host a static website. I can say what is my landing page, what is my error page, and stuff like that. So essentially my microservice deployment architecture in that sense, if I were to look at the different components, would look like, I have a client. The client could talk to CloudFront. CloudFront basically offers the CDN network from AWS, which could then talk to Route 53, which is basically my domain name server, which could then talk to my S3 bucket. S3 bucket is where all my HTML, JavaScript, everything is sitting over there. Now, the HTML could directly invoke my REST API, or from the client itself, I may be directly invoking the API gateway, which would then be invoking my serverless functions and essentially talking to the Couchbase at the back end. So lots of ways by which you can skin this cat essentially, but this is sort of a broader architecture. Let's go back and look at our definition once again. This is sort of pretty much the last slide here. But what we're saying is suite of small services. Each service is essentially a Lambda function, each running in its own process, because Lambda functions, once you run it, once the Lambda function is gone, the runtime is gone for you. It's complete clean in that sense. Each of them is independently deployable because each Lambda function is running in its own process. Behind the scenes, today they're using LXC containers, but it's completely transparent to you. There is no management, no scaling that you need to worry about it from your perspective. We talked about different languages that are supported by Lambda function, and it's completely independent of the data store technologies. So for all of the Amazon concepts, I would recommend you to go to aws.amazon.com. Couchbase, of course, is couchbase.com. And all my slides and the demos that I talked about are available on this github.com/arun-gupta/serverless. So that's pretty much the end of my time. If you like this talk, I would recommend you to go to the DevOps app and give us a good rating. That brings me back here again next year. Thank you.